Okay, so today we're going to look at shading inequalities and regions on graphs. Um, in order to begin, you first need to be acquainted with straight line graphs, y equals mx plus c, coordinates, and the basics of inequalities. If you're not so confident on inequalities, you can go to Corbett Maths and look at videos 176, 177, and 178 before you start this video. Okay. So we're starting off with a problem. You are required to design a picture frame with the following parameters. Its width must be more than 8 decimeters, height less than 8 decimeters, and its height must be greater than its width. So these coordinates along the x-axis is width, along the y-axis is height. So if we take a random point over here, that has a width of 7 and a height of 4. So that point is 7, 4. It has a width of 7 and a height of 4. So how are we going to make sure that our width is more than 5 decimeters? Well, we can draw a line along that area over there, and that area over there is a width of 5. So anywhere on this side of that line has a width of greater than 5. Height has to be less than 8 decimeters. So that line over there shows where the height is 8 decimeters. All of these coordinates here have a height of 8 decimeters. If the height is less than 8 decimeters, we want anywhere on this side of the line. Anywhere on this side of the line has a height of less than 8 decimeters. Now its height must be greater than its width. So we're going to draw a graph showing where the height is equal to its width. So here its width and height are both 1. There its width and height are both 2. There the width and height are both 3, for example, and so on. Okay, so its height must be greater than its width. So if its height is going to be greater than its width, it has to be above this line. Anywhere above this line, you can pause the video and check if you want. Anywhere above this line has a height greater than its width. So for example here, this point here is 2, 7. There the height is greater than the width. So what we want is anywhere on this side of the width equals 5 line, so anywhere here, anywhere below the height equals 8, so anywhere there, but also anywhere above this line over here where the height is greater than its width. So actually, this is the region we want. You can pause the video and check any point there meets all 3 of the parameters. So for example, here the width is 6, so it's more than 5. The height is 7, so it's less than 8, and its height is greater than its width over here. So this point here meets all 3 parameters, and we can shade that region there because it meets all of those parameters. Let's look at another example. Its width has to be more than 2 decimeters. So let's draw a line where the width is equal to 2 decimeters. Anywhere along this line, the width is 2 decimeters. So we could have a width of 2, height of 1, width of 2, height of 2, width of 2, height of 3, and so on and so on. Anywhere on this side, the width is greater than 2 decimeters. We need a height of less than 9 decimeters. So it has to be below this horizontal line to have a height of less than 9 decimeters. So far we want a width of greater than 2 and less than 9, so that gives us all of this area here. But its height must be more than double its width. So this line here, along this line, the height is exactly double the width. So for example here, the width is 1, the height is 2. The width is 2, the height is 4. The width is 3, the height is 6. Its height must be more than double its width. So we want anywhere above the line. Anywhere above the line, the height is more than double its width. So we wanted a width of more than 2, which is this over here. We wanted a height that was less than 9, which was below this horizontal line over here. But we wanted a height more than double its width. So anywhere above this line, the height is more than double its width. Anywhere above that line. And what we'll find is the region we want that satisfies all of our parameters is this region over here. Let's take this point as an example. The width is 3, so it's more than 2. The height is less than 9 because the height is 8 over here. Its height is more than double its width. Its height is 8, its width is 3, so the height is more than double its width, and anywhere in this region here fits all three of the parameters that we want. Moving on again. Width more than 3, height less than or equal to 8. Now if it's less than or equal to 8, we use a solid line, and that's very important. I'm going to come back to that at the end. If it's less than or equal to, we use a solid line. That's just part of the notation that we use. Its height must be at least 2 decimeters more than its width. Okay, so along this line here, the height is 2 decimeters more than its width. So width of 1, height of 3, 2 centimeters more than its width. Width of 2, height of 4, width of 3, height of 5, width of 4, height of 6. So along this line, its height is 2 decimeters more than its width. So we want anywhere above the line, the height is going to be more than 2 decimeters more than its width. Okay, so let's pick a point in the shaded region that fits all three parameters. Let's pick that point there. Its width is more than 3. Its height is less than or equal to 8. Its height is more than, it's at least 2 decimeters more than its width. Okay, the height is 7, the width is 4, so it is at least 2 decimeters more than its width. Okay, now part of the shaded region will be along the solid line, so we could have this point, for example. Okay, it's on the solid line, so its width is more than 3 decimeters, its height is less than or equal to 8 decimeters, and its height is at least 2 decimeters more than its width. Okay, so that point over there, its height is at least 2 decimeters more than its width. Its width is 5, its height is 7, which is at least 2 decimeters more than its width. Okay, width at least 2 decimeters again, height less than or equal to 8. Its height must be at least 1 decimeter more than double its width. And this is getting a little bit complicated, so in a minute we're just going to start using y and x. But just pause the video and figure out where that last line is going to go. Its height must be at least 1 decimeter more than double its width. And that's where the line is going to go. Okay, at least 1 decimeter more than double its width. Double its width, add 1. Double its width, add 1. So along this line here, its height is at least 1 decimeter more than double its width. So that's our shaded area there. Okay, and as I said, now we're just going to go for the letters, the algebraic notation, because the worded one got a little bit too difficult in the previous slide. So now we're just going for width greater than 4, a height less than 7, and a height greater than its width. And that's going to be our shaded region over there. It fits all three parameters. You can check any point in there and you'll see what I mean. Okay, so now we're just going back to the old-fashioned x and y axis because algebraically that's actually what we need to know. So we need an x value that's greater than 3. So we've drawn x equals 3. Along that line, all the x values are equal to 3. Anywhere on this side, the x values are greater than 3. We need a y value that's smaller than 7. So that's anywhere along this side of that horizontal line. The y values are all smaller than 7 here. So for example, this point here, 7 and 5, the x value is 7. The y value is 5. So the x value is greater than 3. The y value is less than 7 at this point here. Okay. Y is greater than 0.5x plus 3. So the first thing we do is we draw the line y equals 0.5x plus 3. And that's going to have a y-intercept of 3. It's going to have a gradient of half. So this is the line y equals 0.5x plus 3. If we want y to be greater than 0.5x plus 3, we want the area above the line. These are all the values up here where y is greater than 0.5x plus 3. Y is getting bigger and bigger. Y is the y value, which is these numbers here. These numbers are getting bigger and bigger above the graph. So anywhere above that graph, y is greater than 0.5x plus 3. And it's important to remember we first have to draw the line y equals 0.5x plus 3, so that we know anything above it, y is greater than 0.5x plus 3. So the shaded region we want is this one over here. X is smaller than 9, so x is going to be anywhere on that side of that line. Y is smaller than x. Okay, so we draw the line y equals x. Okay, y equals x, 1 and 1, 2 and 2, 3 and 3. Anywhere along this line, the x value equals the y value. Anywhere below the line, the y value is smaller than the x value. So for example here, 5 and 2, the y value is 2, the x value is 5. The y value is smaller than the x value. Now for this one, we're going to draw the line y equals 0.5x plus 2. It's going to go through the y-axis with a gradient of a half. It's going to go through the y-axis at 2 with a gradient of a half. Okay, so that's this one, a gradient of a half. Distance in y is 1, distance in x is 2. It's got a gradient of a half. So we want y to be greater than 0.5x plus 2, which is this region, this quite poorly shaded region over here. Apologies for that. This region over here satisfies all three of those parameters. Okay, the x value is smaller than 9, the y value is smaller than the x value, and the y value is greater than 0.5x plus 2. So if this is the line 0.5x, y equals 0.5x plus 2, we want the points greater than that, but we want the points smaller than the line y equals x. So this is the line y equals x. All the points below that line, y is smaller than x. X is greater than, okay, this one. Okay, so this one isn't obvious at the moment. X plus y is greater than 10. So let's draw the line where x plus y equals 10. So that point's going to go through 0, 10, 1, 9, 2, 8. Okay, along this line, the x value plus the y value equals 10. Okay, 1 plus 9 is 10, 2 plus 8 is 10. So we want anything above this line. Anywhere above this line, the x value plus the y value is greater than 10. Let's pick this point as an example. That's the point 5, 9. The x value plus the y value is greater than 10. 5 plus 9 is 14. So we want all the points above this line. Okay. We want the y value to be smaller than 9. So we want all these bits here. We want the x value to be smaller than 4. So this is what we end up with. These points, the y value is smaller than 9. The x value is smaller than 4. X value plus the y value is greater than 10. So for example, 3 and 8. X value is 3, which is smaller than 4. The y value is 8, which is smaller than 9. The x value plus the y value is greater than 10. 3 plus 8 is 11, which is greater than 10. So all of these are possible points that we could use. So we can shade in all of those points because that's the region that satisfies all three parameters. Okay. Gets a little bit more tricky. Y is smaller than 2x. Y is greater than 4. X plus y is smaller than 10. Okay. So that's where x plus y equals 10. This, I'll go back one. This here, y equals 2x. Y equals 2x. There's no y-intercept. The gradient is 2. The y value along this point is 2 times the x value. Double the x value, you get the y value all the way along this graph over here. Okay. So, and the last one is y is greater than 4. Okay, so y is smaller than 2x. So we draw the line y equals 2x. Because y is smaller, anywhere below that line, y is going to be smaller than 2x. Okay, y equals 4. Anywhere above that line, y is going to be greater than 4. X plus y is smaller than 10. This is the line x plus y equals 10. Anywhere below that line, x plus y is going to be smaller than 10. So all of these points here, let's pick that as an example, 3 and 5. The y value is smaller than 2 times the x value. The y value is greater than 4. The x value plus the y value is smaller than 10. 3 plus 5 is smaller than 10. So draw the line first. So draw the line for y equals 2x. This is the line for y equals 2x. Y is smaller than 2x is below that line. Yeah. Okay. Y is smaller than 2x plus 4. Firstly, I'm going to draw this bottom one. Y is smaller than minus x plus 7. Okay, that's this line here. Y equals minus x plus 7. A gradient of minus 1, a y-intercept of 7. Y equals minus x plus 7. We want y is smaller than minus x plus 7. So we want below the line because it's smaller than. Okay, so y is this is where the y values are getting smaller and smaller and smaller. Y value of 5, y value of 4, y value of 3. These are where the y values are getting smaller and smaller. Okay, we want y is smaller than 2x plus 4. So we draw the line y equals 2x plus 4, which is this line here. Y equals 2x plus 4. We want the y values that are smaller than this. We want the y values to be smaller than 2x plus 4. We want the y values to be getting smaller, which is over here on this side. Okay, but we want y to be greater than 5. So that leaves us this small region here, because that's y equals 5. We want y to be greater than 5, which is there. Okay, let's look at the last one. X is smaller than y minus 3. Okay, so let's take that and see what we can do with that. Let's add 3 to both sides. Okay, the minus 3 and the plus 3 cancel out. Okay, so we're left with y is greater than x plus 3. Okay, by balancing, we've got it into the form y equals mx plus c, or y is greater than mx plus c. We can draw the line y equals x plus 3 here. Y equals x, there's a gradient of 1, a y-intercept of 3. Y equals x plus 3. That's this line here. Okay, we want y to be greater than x plus 3, so we want a region above this line. Okay, we want x to be greater than 4, and we want y to be greater than 5. Now this is a little bit different. It's not the triangle we're looking at here. Can you see? Try and figure out where that region is going to be. Pause the video and try and figure that out. Okay, that region is going to be up there. Okay, y is greater than x plus 3. So this is the line y equals x plus 3. We want y to be greater. We want the y values to be getting greater and greater and greater and greater. So that's where the y values are greater. X is greater than 4. X values are getting bigger than 4. Okay, and y is greater than 5. All those points there, y is greater than 5. Okay, so the last thing is what you have to remember is when you're using the notation greater than or equal to, or less than or equal to, you use a solid line. Use a solid line. Okay, there's a solid line beneath that symbol over there, and that's a memory aid. This is a solid line. This is a solid line, and there's a solid line there. There's no solid line beneath that. This is a dotted line. Okay, so if you want points where y is equal to or greater than or smaller than, sorry, equal to or greater than, equal to or smaller than, you use the solid line, and if there's no equal to sign underneath, you use the dotted line. Okay, so as I said, if these confuse you, these signs, you need to go to Corbett Maths 176, 177, and 178. Okay, watching the video isn't enough. You now need to go to Corbett Maths 180, 181, and 182. Attempt the questions on the worksheet. There's answers there, and you need to try some of the questions to make sure that you can do it. Yeah, that's an introduction to linear regions, linear graphs and regions, linear inequalities, and hopefully that's been helpful. And if you need any more help, make sure you, anything you don't understand, you speak to someone who understands. Okay, thank you very much. Good luck.